previous owner's wiring seems to be incorrect and potentially unsafe. In a 240-volt system, the black and white wires are line conductors, commonly referred to as hot wires, and should be connected to each leg of the GFCI breaker. The bare copper wire must be connected to the ground bar in the service panel and not the neutral bus bar. The white connection on the breaker is usually the neutral, not the ground. In the previous setup, it may appear that the neutral is also serving as the ground, but this is incorrect and creates a hazardous situation. It is impossible to install a GFCI in a 3-wire 240-volt system without a ground connection. A GFCI relies on the ground to detect current imbalances between the line conductors and the neutral conductor. The plan to install a new 4-wire setup is correct and provides a safe and proper connection for the SPA. As an additional consideration, check the wiring of the 220 volts outlet in the garage as well, as it also may have been wired incorrectly. It is recommended to always have electrical work performed by a licensed electrician to ensure safety and code compliance. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. Grounding is a critical aspect of electrical safety, and it's essential to understand its function and how it integrates with GFCI protection. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and de-energize the circuit quickly in the event of a fault. The purpose of a ground is to provide a safe path for electrical current in the event of a fault, such as when a live wire comes into contact with a metal enclosure. This ground connection helps to quickly trip the circuit breaker or fuse, cutting off the power and preventing electrical shock. A ground fault circuit interrupter, or GFCI, is a device designed to protect people from electrical shock. It works by monitoring the current flowing to and from an electrical device. If there is an imbalance, meaning some of the current is leaking to ground, the GFCI will quickly trip the circuit, cutting off the power. The GFCI protection is crucial in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect even small imbalances in current, as little as 5 mA, and trip the circuit within milliseconds. This rapid response time helps prevent serious electrical shocks. When working with electrical systems, it's essential to use the correct wiring methods and materials. The NEC specifies the types of wires, cables, and conduits that are appropriate for different applications. Using the wrong materials can create safety hazards and increase the risk of electrical fires. For example, using undersized wires can cause them to overheat and potentially start a fire. The NEC also provides guidelines for the proper installation of wiring, including requirements for wire splices, terminations, and support. Improperly installed wiring can create loose connections, which can lead to arcing and overheating. When dealing with a 240-volt circuit, there are typically 2 hot wires, a neutral wire, and the ground wire. The hot wires carry the electrical current to the device or appliance, while the neutral wire provides a return path for the current. The ground wire is there for safety to provide a path for fault current in the event of a short circuit. In a properly wired 240-volt circuit, the 2 hot wires are connected to separate terminals and the breaker, while the neutral wire is connected to the neutral bus bar in the panel. The ground wire is connected to the ground bus bar in the panel. The NEC specifies the minimum size of wires that can be used for different circuits. The size of the wire is determined by the amount of current the circuit is expected to carry. Using undersized wires can cause them to overheat, which can damage the wires and create a fire hazard. For example, a 50-amp circuit typically requires a minimum of number 6 American wire gauge, or AUG, copper wire. The NEC also specifies the type of insulation that is required for different wiring applications. The insulation is designed to protect the wires from damage and prevent electrical shock. The type of insulation required depends on the environment in which the wires will be installed. For example, wires that are installed in wet locations must have moisture-resistant insulation. When working with electrical systems, it's important to follow all safety precautions. Always turn off the power to the circuit before working on it, and use appropriate personal protective equipment such as safety glasses and gloves. It's also a good idea to have a qualified electrician inspect the wiring to ensure that it's safe and up to code. The equipment grounding conductor, or EG, is a critical safety component in electrical systems. It provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse quickly in the event of a fault. The EGC is typically a bare or green insulated wire that is connected to the metal enclosures of electrical equipment, such as appliances, panels, and junction boxes. The EGC is connected to the grounding electrode system, which consists of one or more grounding electrodes, such as ground rods or metal water pipes, that are buried in the earth. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for light and currents to dissipate safely. The size of the EGC is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of the EGC for different circuit sizes. Using an undersized EGC can compromise the safety of the electrical system. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. Bonding helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. Bonding is required for all metal enclosures, raceways, and equipment that are likely to become energized. The NEC specifies the methods and materials that are used for bonding. The grounding electrode conductor, or GEC, connects the grounding electrode system to the electrical system. The GEC is typically a copper wire that is connected to the ground bus bar in the service panel. The size of the GEC is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the GEC for different service sizes. The neutral conductor carries the unbalanced current from the load back to the source. In a 240-volt circuit, the neutral conductor is typically not used, as the load is balanced between the two hot wires. However, in some cases, the neutral conductor may be used to provide 120 volts power for lighting or other small loads. The neutral conductor is connected to the neutral bus bar in the service panel. The neutral bus bar is isolated from the metal enclosure of the panel. The NEC specifies the requirements for the installation of neutral conductors. Overcurrent protection devices, or OCTs, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. OCTs are sized to protect the circuit conductors from overheating. The NEC specifies the maximum size of OCTs that can be used for different circuit sizes. When an overcurrent occurs, the OCT will trip, interrupting the flow of current and preventing damage to the circuit conductors. Short circuits occur when there is a direct connection between two conductors that have different potentials, such as a hot wire and a neutral wire. Short circuits can cause a large amount of current to flow, which can quickly overheat the circuit conductors and cause a fire. Ground faults occur when there is a connection between a hot wire and the ground. Ground faults can cause a shock hazard if someone comes into contact with the grounded object. GFCIs are designed to protect people from ground faults. Arc faults occur when there is an unintended electrical discharge between two conductors. Arc faults can generate a lot of heat and can ignite nearby materials, causing a fire. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults. The service panel is the main distribution point for electricity in a building. The service panel contains the main breaker, which controls the flow of electricity to the entire building. The service panel also contains the branch circuit breakers, which protect individual circuits in the building. The service panel must be properly grounded and bonded to ensure safety. The NEC specifies the requirements for the installation of service panels. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes are typically made of metal or plastic. The NEC specifies the types of electrical boxes that are permitted for different applications. Electrical boxes must be properly grounded and bonded to ensure safety. Conduits are used to protect and route electrical wires. Conduits are typically made of metal or plastic. The NEC specifies the types of conduits that are permitted for different applications. Conduits must be properly supported and secured. Wiring methods refer to the ways in which electrical wires are installed. The NEC specifies the wiring methods that are permitted for different applications. Common wiring methods include conduit, cable, and surface raceway. Electrical equipment must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. Listing and labeling indicate that the equipment has been tested and meets safety standards. The NEC requires that all electrical equipment be listed and labeled. Electrical work must be performed by qualified individuals who are familiar with the NEC and have the necessary skills and knowledge to perform the work safely. Many jurisdictions require that electrical work be performed by licensed electricians. Electrical inspections are performed by qualified inspectors to ensure that electrical work complies with the NEC and is safe. Electrical inspections are typically required for new construction and renovations. Permits are required for many types of electrical work. Permits are issued by local building departments and are used to track and regulate electrical work. The NEC is updated every 3 years. It is important to stay up to date on the latest changes to the NEC to ensure that electrical work complies with current standards. The NEC provides specific requirements for the wiring of spas and hot tubs. These requirements are designed to protect people from electrical shock hazards. The NEC requires that spas and hot tubs be connected to a dedicated circuit with a GFCI protection. The NEC also requires that spas and hot tubs be bonded to the grounding system. The NEC provides requirements for the location of electrical equipment near spas and hot tubs. Electrical equipment must be located at a safe distance from the water to prevent electrical shock hazards. The NEC provides requirements for the type of wiring that is permitted for spas and hot tubs. The wiring must be suitable for wet locations and must be protected from physical damage. It is important to consult the NEC in local codes to ensure that the wiring of spas and hot tubs complies with all applicable requirements. A double-pole GFCI breaker is used for 240-volt circuits. It takes up 2 slots in the electrical panel. It protects against ground faults on both hot wires. When installing a spa, use a 4-wire system. Connect both hot wires to the breaker. Connect the neutral wire to the neutral bus. Connect the ground wire to the ground bus. This provides a safe and reliable electrical connection. Always disconnect power before working on electrical systems. Use appropriate safety gear such as gloves and eye protection. If you are not comfortable working with electricity, hire a licensed electrician.